evaluate expressions involving inverse trigonometric functions. Well, if I go ahead and look at a trigonometric function, I know the input is the measure of an angle, and the output would be a value, some real number. When you look at an inverse trigonometric function, you're interchanging the domain and range. So if I write the arc sine, I'll evaluate it at that real number, that value, and the output would be the angle. So the arc sine of 1/2 is pi over 6. Similarly, we would say the arc cosine of the number 1 is the angle 0 radians. Here's the problem, though, with trig functions. They're periodic. Their shape repeats over and over, and they all fail the horizontal line test. So how do we get these inverse trig functions? We restrict the domain. On sine, if we restrict the domain from negative pi over 2 to pi over 2, we'll get all the outputs from negative 1 to 1, and the function's 1 to 1 on that domain. Now remember, that domain for the sine function will be the range of the arc sine function. For cosine, we would have to restrict the domain differently. We would have to restrict the domain on 0 to pi to capture all the outputs of my cosine function. And if we do that, this function again is 1 to 1, but remember, this restricted domain on the cosine function is the output is the range of the arc cosine function. And for tangent, if we restrict the domain from minus pi over 2 to pi over 2, being very careful not to include the endpoints, we'll capture all the outputs for tangent. And again, my restricted domain for tangent, negative pi over 2 to pi over 2, that's going to be the range for the arctangent. So for these three inverse trig functions, the domain of arc sine, that's the range of the sine function. And that sine function, we know, I can look at it from the perspective of a unit circle. I'm looking at the y coordinates. That would go from minus 1 to 1. And that range would be where we restricted the domain to get all the positive and negative y coordinates. And that was minus pi over 2 to pi over 2. For my inverse cosine function, gosh, that will mean that we want all the values of x coordinates on the unit circle, because that's just going to be the outputs for the cosine function. And that would be what? That would be
negative 1 to 1.
Negative 1 to 1. And we restricted our domain differently for cosine. We went from 0 to
From 0 to pi.
0 to pi, so that becomes the range of the arc cosine, and that'll catch all of those values that the cosine function can have as outputs, all those x coordinates.
Right.
And lastly, for tangent, the domain was the old range of the tangent, and that was negative infinity to infinity. And the range is going to be what we restricted our domain to, and we restricted our domain to
negative pi over 2 to positive pi over 2.
Beautiful. So that means when I go ahead and evaluate these inverse trig functions, my outputs have to, and this is what's key, they have to be between negative pi over 2 to pi over 2 inclusive for arc sine. They have to be from 0 to pi inclusive for arc cosine. The answers have to be, the evaluations.
Right.
And the only evaluations that are acceptable for arctangent are negative pi over 2 to pi over 2, non-inclusive. So the first thing I'm going to do is say, all right, let's take a look at each of these 4 questions and ask ourselves if we can evaluate the arc sine of a half. So first thing we do is we write down the arc sine of a half is equal to something. Okay? So I'll go ahead and say it's equal to a. So that means the sine of a, the sine of that, has to be a half. And we know the sine of pi over 6 is a half, and we're done. Very straightforward. You interchange the domain and range for your inverse trig functions, and you got it.
Right.
For the next problem, we're going to go ahead and say the arc sine of what? The arc sine of
negative 1/2.
negative a half, and that would be equal to, say, a, which would mean the sine of what?
The sine of a is equal to negative 1/2.
Very good. Now we just have to be very careful. We want to make sure that whatever a is between negative pi over 2 and pi over 2, because that's my range for the arc sine. So I know it's not pi over 6, it must be
Negative pi over 6.
Negative pi over 6, very good. Now for arc cosine, it's a similar thought process, isn't it? My arc cosine of a half is equal to what? Is equal to?
A.
A, which means my cosine of what? Cosine of?
Cosine of A is equal to 1/2.
Good. And that angle A would be pi over 3, wouldn't it?
Yes, it would.
When I take a look at the arc cosine of negative a half, then all we're going to do is say I'll have the arc cosine of negative a half equal A, which means what? Which means the?
The cosine of A equals negative 1/2.
Very good. And I have to be very careful because whatever value I pick has to be from what?
From 0 to pi.
0 to pi, good. So I think of my reference angle there in the second quadrant. And if my reference angle has to be pi over 3, I know the rotation out to it would be?
Would that be...
So I'm going from pi back pi over 3 units. So it would be, and if I got a common denominator, I guess it would be 3 pi over 3 minus pi over 3. That would be?
That would be 2 pi over 3.
2 pi over 3. Very good. Thank you.